Ladies and gentlemen, our guests for sure have a lot of interesting stories to tell, but to give you the chance already to join in our discussion, and maybe you know this format already from Dijon and from Glasgow, we agreed to start in a first round with pretty short key statements from the agency's head, maybe a resume of the year, ongoing operations, outlook into next year. We were here. And we've scheduled only 5 minutes per person. And if you joined the heads of agencies meeting the 2 last years, maybe you remember that there's always a sidekick with me on the stage. This bell will help me to remind you, distinguished gentlemen, when you're running out of time. So if I have to do so, please now let me apologize in advance. In the second round, we'd like to discuss several topics of current interest here on the podium, and after that, and that's the reason for the bell, you'll get the chance to join in our discussion. We have a couple of co-moderators here in the hall, so if you would like to raise a question to the heads, you can give them a sign. They will hand over a paper, this kind of piece of paper to you, and then you can write down your question, and my colleagues will collect your questions during our second round and take your topics then to the podium. Maybe we won't be able to answer all your questions, unfortunately, but I think on the IAC homepage after that event, your questions will be listed and I suppose also answered. So maybe I can ask my colleagues, the co-moderators, just to raise their hands so everybody can see where you are, who you are. Over there I see, and I think over there in the background also. So give them a sign, and we are looking forward to have your questions here on the podium also. So now we start with our round of statement, and we begin with the agency which is presenting us a lot of historic moments in these days. The newest one is the moving of Space Shuttle Discovery to the launch pad 39A just some days ago for the last time. Mr. Bolden, we are in the autumn of an exciting year, aren't we?
We are very much so, and it's a pleasure for me to be here. Let me thank all of you for allowing us to get together for this forum. For students in the audience, I'm probably not going to impress you, but I'm going to try. Many of you are accustomed to me using notes, handwritten. I'm trying to go cold turkey to technology, so if my battery dies, you'll hear me mumble. But I do want to take an opportunity to talk about NASA's past year.
Excuse me, just take it a little bit more closer, the mic.
I'll talk a little bit about what we did in the past year, because it was actually a fantastic year for us. People tend to, when we talk about NASA, we tend to get really hung up on human spaceflight, which is the most dramatic thing we do. But NASA, the National Aeronautics and Space Administration, has four major mission directorates that do lots of great things, and I want to take an opportunity just to talk a little bit about our year. Our Science Mission Directorate over the past year has continued our understanding of Earth, Sun, and the solar system and the universe, with 59 science missions in operation and 30 more in various stages of development. Over half of those missions have significant international components, and that's very important for us to talk about here, international cooperation, and I will talk about it a lot more. NASA's Earth observing satellites have continued to provide a significant portion of the global environmental observations used for climate change and other Earth science research. In parallel, NASA has continued a robust program of ground and airborne research, including NASA Icebridge airborne campaigns in both the Arctic and the Antarctic, to maintain the critical ice measurements during the gap in time between NASA's ISAT-1 and ISAT-2 satellite missions. Our planetary missions made new discoveries and returned fascinating images, including a previously unknown large ring of Saturn and a near-complete map of the surface of Mercury. Mars continues to intrigue with thick and expansive layers of ice just below the surface at mid-latitudes. Although the Mars rover Spirit stopped communicating with us in March, this week Opportunity passed the estimated halfway point of approximately 19-kilometer journey from Victoria Crater to the much larger Endeavour Crater. The golden age of astrophysics from space is also continuing, with 14 observatories in operation. The Kepler telescope discovered a number of exoplanets, ranging in size from Neptune to larger than Jupiter. Additional discoveries are anticipated in the coming months and years. NASA's newest space observatory, WISE, or the Wide Field Infrared Explorer, has captured its first look at the starry sky, and its sky survey in infrared light has begun. The Hubble Space Telescope is also continuing to operate at its peak performance, thanks to the very successful servicing mission STS-125 by the Space Shuttle. Our heliophysics satellites, such as Stereo B and the Solar Dynamics Observatory, continued to provide not only a steady stream of scientific data for NASA research programs, but also a significant portion of critical space weather data used by government agencies for support of a wide range of activities in space. SDO is providing images of the sun of unprecedented resolution, yielding new understanding of the causes of solar variability and its impact on Earth. These data are used for operating satellites, optimization of power transmission networks, and to support communications, aviation, and navigation systems. In aeronautics research, we have been actively working with the Federal Aviation Administration and others to develop the air transportation system of tomorrow, what we call the Next Generation Air Transportation System, or NextGen. If you go to our website, you'll see some of the prototype vehicles in which we may be traveling in the future. In space operations, the Space Shuttle flew 4 times since the last IAC, delivering equipment and supplies to the ISS to support a 6-person permanent crew and expand ISS research capability. In February, Space Shuttle Endeavour delivered the node Tranquility and the cupola, and in May, Atlantis delivered the Russian mini research module. Working closely with our international partners, we are rapidly approaching the completion of the assembly of the International Space Station, the largest crewed spacecraft ever assembled, measuring 243 by 356 feet, with a habitable volume of over 30,000 cubic feet and a mass of 846,000 pounds, and powered by arrays which generate over 700,000 kilowatt hours per year. The ISS represents a unique research capability for the conduct of a wide variety of research, which will help us better understand how to keep astronauts healthy and productive on long-duration space missions. While it has been a very busy year, we have multiple activities just ahead of us. In November, Space Shuttle Discovery will deliver an Italian-built permanent multi-purpose module to the ISS that will significantly expand the station's storage volume, and ISS Partnership will celebrate the 10th anniversary of permanent human presence on the International Space Station, a major milestone to all who have contributed to this monumental achievement. In February, Space Shuttle Endeavour will carry the Alpha Magnetic Spectrometer and attach it to the station's truss. The AMS is a particle physics experiment developed by a Nobel laureate that will contribute to understanding the universe's origin. This same mission will launch a robotic crew member, Robonaut 2. We kind of call it R2. R2 was developed through an agreement between NASA and General Motors for use in the auto industry and will now be tested for its applications in space. An active year to be followed next year by ongoing intense operations in science and aeronautics research, and a new direction for exploration and human flight that I want to discuss with all of you later. So thank you very much for allowing me to make that quick summary.
Thank you very much. Thank you very much, Mr. Bolton, also for keeping the time. But as a former astronaut, you know what a countdown means. Thank you. Yeah, I'd like to hand over to Monsieur Dordain for his statement.
Okay, thank you very much. So I shall not go as fast as Charlie, but does not mean that I have less to say. And I would like to report that in the last, since the last Congress, which took place 1 year ago in Dijon, there was a lot of events in Europe, because the events in Europe are not only at ESA, but Europe is made of member states, ESA and the European Union, and I would like to report what has happened in Europe in general, and I would put that in one short sentence: a lot of science and discoveries. I must say last year was a year of science and discoveries. just to mention a few. Speaking of the solar system, we had the flyby of Lutetia by Rosetta, and I hope that you have seen the fantastic pictures taken by Rosetta on Lutetia. And beyond the solar system, the universe, with the first image coming from the two fantastic telescopes, Herschel and Planck, which are today at the second Lagrangian point, and which are exploring the universe. And we can say that Herschel and Planck are changing the universe, because the universe is what we know. And with Herschel and Planck, we know much more than what we knew before. And we are getting with Planck a little bit closer to the Big Bang. And I am very glad to report that the first global image of Planck was issued in a lot of newspapers, including on the front page of the Financial Times, demonstrating that it's not only science, it's more than science. And that it's what we have done on the solar system and the universe. I would like to say that all these missions are made in cooperation, as Charlie was saying, and especially cooperation between ESA and the national space agencies. All the instruments of these fantastic laboratories are provided by the national space agencies of Europe. In Earth science, we have launched 3 satellites dedicated to environment and climate change, with the launch of Goche first for the gravitational field, and we have got already 2 maps of the gravitational field of planet Earth. And now we are continuing. Goche is working well after some difficulties we had in July, but that is over. And we are continuing to get scientific data from Goche. And as you know, and this is the name of Goche, from this gravitational field we shall have a lot of information on the ocean circulation. And the ocean circulation is a significant parameter for climate change. The second one was SMOS, for soil moisture and ocean salinity, and that is also providing a lot of information on the water cycle in the atmosphere. And the third one, Cryosat, which was launched recently, and which is starting to give some information on the polar ice, not only on the width of the polar ice, but also on the thickness, which is an important factor. And if you add that the satellite OnVSat and ERS-1, they are still working daily, we are delivering daily data to thousands of scientists all over the world. And there was a symposium organized in Bergen in Norway in June on these Earth observation data. And this symposium collected more than 2,000 scientists coming from more than 70 countries, meaning that the importance of these satellites are going much beyond the borders of Europe. I would like to say that ISS is also, we are partner of ISS, and all the information that Charlie has given are applicable to us. I would like to say that since Columbus has been launched, we have entered the full utilization of our part of the International Space Station, and we are collecting a lot of also science and discoveries from the ISS utilization. As you know, we were planning to organize the first symposium among partners on the results of the utilization of the space station, but this symposium has been cancelled because of the volcano in Iceland. But we plan to reorganize this symposium beginning of next year in Berlin. I would like also to mention, because I wish to report on what is happening also beyond ESA, that the French, they have launched Pika and Prisma, and also the satellite Helios B. The Germans have launched the satellite Tandem X, and the Italians the fourth Cosmos Skymet, completing the constellation. And as you can see, it's a lot going on concerning the Earth observation. And I would like to end that by saying that we shall celebrate this year the 10 years anniversary of the initiative taken by CNES and ESA 10 years ago to create the Charter on Natural Disasters. And since 10 years, a lot of other agencies have joined CNES and ESA, and unfortunately, that Charter on Natural Disasters is called more and more by more and more countries. It's now at 3 times a month average that we, the space agencies, we are asked to provide data for those who need that after a natural disaster. So what is in front of us is the launch of the permanent module for ASI. This is also something that we are looking for. We shall have the launch of Paolo Nespoli in December to the space station for 6 months. We shall have the launch of ATV2 to the space station on time for the reboost of the space station between March and April next year. The launch of AMS, where a lot of ESA member states have contributed to AMS, and there will be Monsieur Vittori on board the space shuttle for an ASI flight, but Vittori is also an ESA astronaut. And soon after, we shall have the first launch of Soyuz from CSG, the result of cooperation between Russia and ESA and Arianespace. And I am sure that before the next Congress, we shall have also had the launch of Vega. So just to say that I shall have still to report some events at the next Congress. Thank you.
Thank you very much, Mr. Dordain. A lot of topics will be discussed, I think, later on also. About the safe landing of Soyuz TMA-18, we got very good news at the weekend, reminding all of us that space activities are never daily routine. So congratulations to this good ending of this trip, Mr. Perminov. We are looking forward to hear your statement now.
Спасибо. Спасибо. Мы очень стремились на Конгресс, поэтому были просто вынуждены устранить срочно неисправность и осуществить посадку.
Thank you very much. We wanted to go to the Congress. That's why we had to work with our technical problems on board of Soyuz very quickly and to resolve this problem quickly.
Okay. Роскосмос активно использует космическую деятельность и рассматривает ее как локомотив инновационного развития.
So Roscosmos is actively pushing ahead space activities, and we believe it to be like a booster to innovative activities.
Не имея, конечно, таких больших средств, как НАСА, мы вынуждены денно и ночно трудиться над решением следующих задач.
And of course, we do not have such funding as NASA has, but we work day and night to perform several tasks.
Мы сохранили высокую интенсивность запусков космических аппаратов и осуществили с прошлого октября за этот прошедший год почти 41% по всему миру запусков ракет-носителей.
So we are maintaining a high rate of Russian space launches starting from last October. So from the last Congress, we have managed to launch about 41% from all launches over the world.
Большое внимание уделять начали развитию российских космических систем связи, особенно второму поколению низкоорбитальной системы связи типа «Гонец».
We are giving attention to the development of Russian satellite telecommunication systems, and for example, for the development of the second generation spacecrafts for low orbit telecommunication constellation Gonets.
В этом году, я думаю, что мы наконец полностью обеспечим функционирование и покрытие всего земного шара навигационной системой ГЛОНАСС. На орбите будут 24 космических аппарата и необходимый резерв из 3-4 аппаратов.
And this year, I hope we'll be able to provide sustainable and uninterrupted services by GLONASS navigation system. We will have 24 operational spacecrafts and 3 or 4 spacecrafts in hot reserve.
В конце года мы должны вывести на летные испытания метеорологический спутник нового типа «Электро». Также большое внимание уделяем космическим аппаратам научного значения.
In the end, this year we will begin orbital commissioning phase for new geostationary meteorological satellite Electro-L, and we also give great importance to the development of scientific spacecrafts.
Для решения перспективных задач мы в этом году обеспечили проектно-изыскательские работы и начнем строительство новой пусковой площадки на Дальнем Востоке.
And in order to support our future missions, we have started works on our new cosmodrome in the far eastern region of Russia.
Что касается международного сотрудничества, то оно достаточно большое, но основное у нас вот на критике это окончание строительства стартовой площадки «Союз» в Гвианском космическом центре.
And we also give great importance to the international cooperation, but what is most important for the moment, we believe, what is most critical is to finish the construction works on a Soyuz launchpad in Guyana, in French Guiana.
Ну, конечно, и второй проект – это Международная космическая станция. Я благодарен всем за поддержку. И вот в трудную минуту действительно чувствовалась поддержка руководителей агентств, и мы вот успешно справились с задачей посадки.
Our second task is, of course, International Space Station, and I would like to thank you all and to thank all the heads of agencies for the support you have given us in well, quite a hard time. So we have seen this support, and we have accomplished this task of safe landing.
С точки зрения перспективы, то начали рассматривать серьезно проекты создания высоконадежных средств выведения тяжелого, сверхтяжелого класса.
As for the future missions, future transportation, we have begun works on the development of new medium to heavy and super heavy launch vehicles.
Тут как бы два направления. Первое – это создание сверхтяжелых ракет-носителей на существующей базе, а второе – разработка прорывных технологий, таких новых перспективных средств выведения для дальнего космоса.
And we see here two main tasks. First one is the development of new heavy lift launch vehicles based on existing state-of-art technologies. And the second one is the development of breakthrough technologies enabling us to travel into deep space.
Запущены опытно-конструкторские работы по созданию универсальной двигательной установки с ядерным источником энергии.
So we have started R&D activities on developing universal nuclear-powered propulsion module.
Ее можно было бы использовать для межпланетных пилотируемых полетов и в качестве межорбитального буксира.
So this module could be used both for interplanetary flights and as interorbital tug.
Ну и другие проекты. Время вышло. Спасибо.
Well, we have several projects too, but well, the time has ended. Thank you very much.
Thank you very much, Mr. Perminov. I think the whole space community is admiring the high-quality routine you're dealing with the Soyuz program. There's no doubt about that. Thank you again. Do you know, ladies and gentlemen, what the meaning of the Japanese word michibiki is? Michibiki, means to lead, and is at the same time the name of the first GPS satellite Japan has launched just 2 weeks ago, and which fields the Japan Aerospace Exploration Agency would like to lead this, perhaps. We will hear now from Mr. Keiji Tachikawa.
Okay. Last year is JAXA's another good year. So I would like to introduce some summary of our developments about the space technology on behalf of JAXA. I would like to begin with my presentation with the asteroid explorer Hayabusa, we call Hayabusa, which has successfully landed in Umera, Australia in June this year. We call Hayabusa project team overcome extreme difficulties with knowledge and science, realized to return to the Earth with a surface sample capsule from asteroid Itokawa and accomplished the 6 billion kilometer space journey for 7 years. The samples of analysis of samples now underway. Next is Akatsuki, we call Venus Climate Orbiter, also known as the Planet C, was launched in May this year. Also, same time, Icarus, the small solar power cell demonstrator, was launched with Akatsuki. We call a space yacht. Another thing is now he said that Michibiki, the first satellite of the quasi-zenith satellite system, was launched in September. Now let's look into international cooperation. I would like to talk about Kibo, the Japanese experiment module on the International Space Station, which is the completion of Kibo operation and space-based experiments on science, engineering, and medicine have been conducted to be utilized for the people's lives and the industries. Many Japanese astronauts are now in charge of advanced missions. Astronaut Noguchi accomplished the nearly 6-month stay in the ISS. During the same period, astronaut Naoko Yamazaki spent nearly 2 weeks in the ISS. So we had 2 Japanese same time on the ISS. This is in March this year, the head of the ISS agency met in Tokyo to review the ISS cooperation and to extend operation to 2020 or beyond. In August this year, Strategic Headquarters for Space Policy in Japan decided that Japan would continue to participate in the ISS cooperation beyond 2016. JAXA also promotes space cooperation for the Asia-Pacific region. The APR-SAF, we call Asian Pacific Regional Space Agency Forum, has been holding annual meetings organized jointly in the Asia-Pacific region. The 16th session was held in Bangkok, Thailand in January this year, in the largest scale with more than 300 participants from 27 countries and regions, and also 10 international organizations. By making best use of this framework, we aim to promote cooperative activities. to explain, we aim to promote cooperative activities to exploit space technology and utilization by countries in Asia and the Pacific for under sustainable development. We are pleased to inform you that the next APR South 17 will be held from 23rd to 26th November this year in Melbourne, Australia. We do hope that you will join us at the APR South 17 with your colleagues. Thank you very much for your attention.
Distinguished delegates, ladies and gentlemen, the Indian space program has been inspired by a vision to utilize space for the common man, and a vision this has been shared, sustained, and enriched as it evolved over the past 5 decades. The fruits of space research are reaching the common people and society, touching their daily life, be it a fisherman, a farmer, a student, patients from remote areas, an administrator or policymaker. Several lives could be saved during natural disasters by the timely information and connectivity provided by the space platforms. What happened after the last Congress was Dr. Nair handed over an excellent organization into my hands, an excellent team, and an excellent program. And it is now my privilege to brief you on what happened, what we are planning to do. OceanSat 2, that was launched a few weeks before the last Congress, is now providing global data on ocean color and ocean winds. And our colleagues from NASA, NOAA, and EUMETSAT have found that the spectrometer data is highly essential for their forecasts. We have launched an Earth observation visualization platform called Bhuvan. Recently, the 16th successful flight of PSLV vehicle orbited another high-resolution satellite, Cartosat 2B, and 4 co-passenger satellites. The flight testing of the Indian cryogenic stage on GSLV D3 was a major step forward. However, we had a problem, and the corrective actions are underway. I hope in the next contest, I would be able to give an update on what we have done. The GSAT-4 communication satellite with Ka-band transponders and onboard processing was an important development, though it could not be orbited by GSLV D3. ISRO's next generation launch vehicle GSLV Mark III, designed to put 4-ton class of satellites into GTO, gained impetus with the successful static testing of L110 liquid core stage and the strap-on solid motor S200. And we note that the S200 is the 3rd largest solid booster of the world. The Indian space program is now on the threshold of a transition towards developing newer capabilities and perspectives and directions. We have geared up for a quantum jump in the missions for next year towards increasing the availability of transponders, enhancing capability for Earth observation, including microwave imaging. ResourceSat 2, radar imaging satellite, and GSAT-12 are getting ready for launch by PSLV. GSAT-5P and GSAT-7 would be launched by GSLV. GSAT-8 and INSAT-3D would be realized with procured launches, and GSAT-10 would follow. YouthSat, built jointly by the university students from Russia and India, and XSAT from Singapore would be co-passengers with ResourceSat 2 to be launched using PSLV in December 2010. 2 Indo-French joint missions are on the anvil. Megatropids, to be launched by PSLV next year, would improve the understanding of energy and water balance in the tropical belt. Altimeter and Argos payloads on board Saral will enhance global ocean observing capability. We have radio occultation sounder instrument from Italy on board 2 Indian satellites. On the navigation front, we have a 3-pronged strategy. Space-based augmentation of Gagan in our region would commence next year. We are working with Russia for joint production of GLONASS civilian receivers, and development of the Indian regional navigation satellite system has made good progress. The discovery of water ice in the North Pole of Moon by scientists from 13 agencies of USA and India using data from MINISAR instruments of our NASA JPL colleagues on board Chandrayaan-1 has been remarkable. Chandrayaan-2 is an Indo-Russian mission with a lander module from Russia, and the launch is targeted for 2013 by GSLV. AstroSat, a multi-wavelength observatory, has collaboration with Canada. Hyla satellites, built in partnership with EADS Astrium for Avanti Communications, has been another example of synergy. And so far, over the last 2 decades, we have launched 25 satellites of other countries, mostly as co-passengers on PSLV. As of now, we have committed to launch another 11 satellites. The future focus would be towards low-cost access to space, Earth observation for environment monitoring, and climate change. ISRO has also initiated studies on critical technologies for human spaceflight. Building human capital remains a priority for us. 150 engineers and scientists graduating for our own Indian Institute of Space Science and Technology would be joining ISRO next year. Finally, ISRO has always enjoyed strong support and goodwill from public and governments. The focus on application has been rewarding and would remain the bedrock of India's space program. The year ahead, I'm sure, would be exciting with a number of national and international missions. Thank you.
Thank you very much. Thank you very much indeed, Mr. Radhakrishnan, and all of you gentlemen for this first round. So maybe please allow me to remind you that you can join in our discussion if you want to raise a question. Plus, just raise your hands. My colleagues will collect your questions and bring some of them then to the podium. Now let's focus on some of the key topics you gentlemen already mentioned. I think we recognize there's a new activity coming up concerning the launch and space transportation technologies. Mr. Bolden, when the Augustine report recommended the stop of the Constellation program and stop of RS-1 and RS-5, I think in the beginning it was a sort of a shock for space community, but now we see that many activities have mushroomed out of this. When you this year presented the President's budget request for 2011, you were talking about reaching the Mars, and I quote, reaching the Mars within weeks instead of nearly a year. Simple question, how?
How do we do that? The challenge for our exploration program is exactly what you point out. There are several challenges that we have. One is overcoming radiation to allow astronauts to survive the transit to Mars. There are a number of ways you can do it. The most unlikely way is to increase the amount of shielding that we use, because that's weight and that detracts from our ability to do what we want to do. Another way to do it is speed. If we cut down on the amount of transit time, our friends at Roscosmos and I have been talking over time. All of us are talking about looking at new in-space propulsion methods, non-chemical methods that will allow us to make it not weeks, but significant months shorter than what we think it would currently take. I will point out that America's exploration program, while some will say we have taken a step back, that is, nothing could be farther from the truth. The exploration program, I think, is now vibrant because we want to do some of the things that were actually enumerated in the vision for space exploration back in 2004 following the Columbia accident, when my predecessor said we are going to Mars and we're going to go back to the moon and we're going to do exploration to asteroids. All those things have been said before. The difference is that now we're actually being given an opportunity to take some of our funds and invest in the technology development that we need to enable us to do that. You're also going, I do have to go back though to the collaboration between science and technology. We look at some of our science missions that are already on the books, and we're looking for ways to capitalize on missions that will be flown or already on the way to Mars or other places in our solar system, and find out if some of those don't fill the bill as a robotic precursor to help us understand some of the challenges that we will need when we send humans to orbit. You're going to see NASA and our international partners cooperate much more in missions where we send robotic vehicles first to find out just how much we can put the human through or how much we can do. So ISS as a research vehicle, as an international research laboratory, I think is finally coming into the fore with a full 6-person crew. We're now starting to do experimentation that will help us understand some of the challenges of going on to places like an asteroid or the moon. So the challenges are many. The two biggest ones for us, as I mentioned, are overcoming radiation and its effects on the human and the central nervous system, and then just the speed by which we get there. So that's where we're focused.
Thank you, Mr. Perminoff. You mentioned also in your first statement that you're working on a new space transportation technology. I think the demands are, as I heard, payload capacity of at least 23 tons, but let's look a little bit further. What do you expect? How similar or how different a new launch system will be compared to what we know today?
Мистер Болден сейчас правильно сказал, что впереди пилотируемые полеты на Марс.
As I understood from Mr. Bolden's statement, and I agree with him that we have a piloted flight to the Mars in the future before us.
В России сейчас идет наземный проект Марс-500.
And currently we have a Mars 500 project undergoing in Russia.
В этом участвуют некоторые европейские страны, представители ЕКА, Китая участвуют в этом проекте. И, конечно, нужно не 1,5 года лететь до Марса, а новые источники энергодвигательной установки, ядерные в частности, они позволяют сделать это в 20 раз быстрее.
И в этом проекте участвуют не только российские представители. So in this project, not only Russian specialists are participating, but also Chinese and European specialists. And, well, of course, we do not have to fly 1 hour and 1 year and a half to the Mars. We have to fly it quicker, and we can do it with new space propulsion methods. We can make our flight quicker by 20.
И, конечно, это очень сложная задача. Нужны энергодвигательные установки такие мегаваттного класса.
Though it's a very difficult technological task, we need to have a propulsion system with powers of about 1 megawatt.
Прекрасно понимаю, что эта задача очень трудная, но ее решать на сегодняшний день крайне необходимо. Мы открыли опытно-конструкторские работы по этому направлению в России.
Though as this task is difficult, that's true, but we have to resolve it. So we have started some R&D works in Russia, which I hope will resolve this problem.
Спасибо.
Thank you.
Thank you. So this is a story where they think in terms much more of giant leaps instead of small steps, maybe. Mr. Dordain, ESA has a launcher which is in pretty good shape with Ariane 5, but what do you define as the current challenge to go further on in the field of space transportation from the ESA point of view?
Okay, as I said already, next year we shall cross a very important step in Europe for space transportation. For the first time in history, we shall exploit 3 launchers instead of 1. So far, we are exploiting Ariane. From next year, we shall exploit Ariane, Soyuz, and Vega, and that it's already a significant step. So just to say that, let's take the steps one by one. But so the next one is that one. Now, we are also reflecting on the future. And the problem is the future is made of transportation for satellites, because we should still make satellites, and transportation for exploration. And I think that the transportation for satellites and the transportation for exploration, it's two different field of reflections. And I fully agree with my two previous colleagues. I think that going to Mars or going to asteroids will require different space transportation systems. And this is where we have to discuss, and we are discussing. Because myself, I am convinced that exploration will be a field of global cooperation, that it's for sure. And we are already cooperating, because we are already making exploration. As Charlie was saying, the International Space Station is already part of the exploration. Robotic exploration is already exploration, and we have a long-term agreement with NASA to make robotic exploration of Mars. But for what concerns human exploration, that we certainly need to talk together and to see which are our needs. And I fully agree that this is not sustainable to take 6 months to go to Mars, and 6 months back and 1 year there. I think that if each mission is taking 2 years, I must say that we should have only young astronauts, and it will be over for me. So we have to work together. Does not mean that we have all to develop the same transportation system. As you know, I am all for developing a common transportation policy, because for exploration, I don't feel that we need 3 times the same type of launchers. We have to talk. We have to see who will provide what, and we have to work together. I would like to end by saying that I am definitely convinced that exploration requires global cooperation. But does not mean that there will not be competition. I think that a little bit of competition is always good, to get the best ideas, to get the best technologies, and to take the best benefit of engineers and scientists competing to each other. So I don't think that cooperation will suppress the competition. We like competition, but provided that this is something that we organize together, but to have scientists from United States, engineers from United States, from Russia, from India, from Japan, from Europe, competing to have the best ideas, it would not be bad. Does not mean that we should not go to Mars together. We should go to Mars together.
Thank you very much. I think this demand for standardization and cooperation is an evergreen topic in space business. Maybe we can come back to this later. I would like to ask Mr. Radhakrishnan, what about India now? You are developing a new vehicle, the, I think, GSLV Mark III vehicle, which is designed to make ISRO fully self-reliant in launching heavier communication satellites, and maybe more, maybe also in the field of manned missions. So what's going on in this field?
The first and foremost thing is we have the PSLV vehicle, which has done 16 successful missions. That's our workhorse. It can do several missions. It can be for a polar mission. It could be for an inclined mission, even for a small communication satellite to GTO. The second point is that GSLV Mark II with the indigenous cryogenic engine is one of our priorities. GSLV Mark III is a more efficient vehicle in terms of the payload fraction, and we do hope another 2 to 3 years we should have the first flight testing of this vehicle. That's the current plan with us. We also work on a few technologies which would bring about low-cost access to space. These are under development. Thank you.
Thank you very much. And just maybe if I close this round with Mr. Tachikawa, you just have developed the launch vehicle H2B, which brought the HTV module into space. So is your opinion for JAXA now the work on new launcher system at the moment is not a very special focus? The job is done, or what is your opinion on that?
JAXA has no idea about such a large, huge transportation system. So we would like to work together with another agencies to develop such a new method to do. But in Japan, we are now developing a small rocket rather than large rocket. We call it Epsilon, which can deliver about 1 to 1.5 ton for a lower orbit. So we would like to have a small rocket system and say large rocket system, but we don't have any super large rocket anywhere now.
Thank you. Cooperation. Mr. Bowden, there's no topic in space which doesn't touch the field of money. Your agency made a big step towards private industry last year, which shall build up transportation system for the lower Earth orbit. Are you sure that will remain cheaper regarding also all the quality checks they have to overcome?
No one is ever sure of anything, and anyone who tells you that they are, I think, are probably fabricating it. It is our belief, however, that NASA cannot do everything. What is most important to us is to do what our nation asks us and what our international friends ask us, and that's to continue to lead in exploration beyond low Earth orbit. If I'm going to do that and I'm going to continue to work with the partners on this stage, then we have to put more of our funds into experimentation and exploration and allow me to pick another method to get access to low Earth orbit. That method right now we take, since the Columbia accident, we have relied dominantly on our Russian partners with Soyuz to gain access for crews to and from the International Space Station. That will continue for some time. We would also like to introduce the commercial industries to commercial access to low Earth orbit, whether it be for cargo or for crew to the International Space Station or other destinations. And I cannot overemphasize other destinations. We are constantly encouraging the private industry to partner among themselves and create destinations for pharmaceutical research, materials processing. There are all kinds of things. There's no reason that people have to be in a 51.6 inclination orbit. That's where the International Space Station is. That is not where business has to be. So we encourage the commercial entities to look for opportunities to create other destinations that will help us help them create a viable commercial industry, and I think we can do that.
Thank you, Mr. Dodin. When you look at the reliability costs and the topic private or institutional setup, you already mentioned the demand for cooperation also in the technical cooperation, so modular concepts and standardization. Where are the concrete demands, the next step to convince everybody of you that, and also the private partners, that there must be to have a look at the coast, a modular concept, whatever you do to handle the next years from the coast side?
I think that this is the interest of everyone, public and private partners, to decrease the cost. I don't think that there is one among us who is looking for increasing the cost. So the problem is how to decrease the cost. And we at ISA, we have created public-private partnership. I would not like to give the impression that we are not asking the private industry to cooperate with us, and we have succeeded. But we have succeeded when there is some interest for the private investors to put their money somewhere. And today, the field where we can find private investors is certainly telecommunications. And we have created a real public-private partnership in telecommunications. And by the way, I have forgotten that the next important event for ISA will be the launch of ILAS, because ILAS is the first public-private partnership between a private operator, Avanti in UK, and ISA. To develop a new telecommunication satellite. It will be followed by AlphaSat, which is a public-private within Marsat, which has been selected on competition, by the way. And the next one is a small GEO mission with the operator Hispasat. So we are all for creating mutual interest between public and private. Now, your question about the cost is not an easy one, because there is no reason that industry is cheaper when they are working for the government or when they are working for themselves. This is the same type of industry. The question is, how many constraints do we put on the shoulders of industry? For example, speaking of Falcon, first of all, I would like to recall that there is not only SpaceX in United States. There is also Atlas, Delta, and they have a market which is so important, and they can sustain several launchers. In Europe, we have not exactly the same type of market. But coming back to the cost, the problem is how many constraints do government put on industry to develop something? I remember, because I am always told that in ESA we have the geographical return, and the geographical return create constraints. Falcon is developed 80% in one industry, while frankly speaking, the Ariane is not developed 80% in one industry. It's much more distributed in different type of industries. But just to give an example that I know, coming from United States, I was working once in my life in United States, and on the Space Shuttle main engine, for example, the Space Shuttle main engine was developed in California and tested in Mississippi, and that was a constraint, I assume, imposed by the public money. This is a type of constraints that a private investor has not, and this is certainly the source of cost, and we have to reflect on how we can make the best compromise between constraints and cost. It's a long way. But again, myself, I repeat, there is no reason for industry to make cheaper products for private investors than for public customers. This should not be the case.
Thank you, and thank you all for writing down so many questions. I already have some here on my table, and I would like to start also with your questions, bringing up to the podium. Also, I think the first question already now have been answered. The agency support of the development of international standards. But I would like to come off Frank. I am sorry I can't read the name completely, but Frank, you're welcome. For the ISS heads of agencies, what are your views on broadening the partnership to other space nations, especially India and China? So maybe we start with China, the collaboration with ISS, and maybe afterwards, and I may ask one of the gentlemen what you think about China participation. So, Mr. Radhakrishnan, the question is concerning the collaboration with ISS topics.
As of now, we have no program to get into ISS. This is something which has to evolve. But as I mentioned earlier, we do have a pre-project activity on the critical technologies required for the human space flight, aimed at putting 2 astronauts into an orbit around the Earth, keep them there for 7 days, and bring them back. So this is currently the thinking on the human space flight.
Thank you. And what about China? You know, I can invite my neighbor for dinner, but I don't know whether he wants to be invited by me. So maybe it's just a question you should ask both sides. Unfortunately, the head of the Chinese agency is not here. But what do you think about cooperation with China on the ISS, as Frank was asking? I don't know, Mr. Bolden or Mr. Perminov or Mr. Dordain would like to answer. Nobody.
Let me go back to the first question. I'll try to answer that question, but let me go back to the very first question. It was one of, what is the possibility of opening up the partnership? We discussed this at the heads of agency last year, and if I remember correctly, the determination we made that is opening up the partnership is extremely difficult because we are involved in treaties. What is not difficult to do is increasing the participation on the International Space Station. And I will ask my colleagues here and Bill Gerstenmaier and some others to help me, but as I recall, what we said was we encouraged the partners, the member nations, to offer the opportunity on a bilateral basis to partner with non-traditional partners, if you will. You always hear us talk about non-traditional partners. Nations that otherwise would not be able to participate in spaceflight, who may offer some small project or component, they can partner with the United States and we can take them along to the International Space Station, but that's not opening up the partnership. The partnership was built over long years and much effort, and I think we run a risk of, sometimes you can get too good. In terms of China, China is a spacefaring nation, one of 3 nations, by the way, that has the capability of putting humans into orbit on their own. And my understanding is that they have ideas about what they want to do, and I know that they talk to every one of my international partners, and that I think is good. So I look all the time and I ask my partners, how are your talks with the Chinese going, and we shall see how things work down the road. I am one who never says never.
Thank you. Maybe on the long run, international cooperation, Monsieur Dodon is always talking about, it's necessary maybe for all. We will see. I have another question, maybe following also the topic of new rocket systems we had here on the podium. It's from David Todd and it goes to Mr. Perminov. Maybe 2 questions here. What mass to low Earth orbit is Roscosmos Super Heavy Lift rocket going to carry? It's a very special question. And the second I add directly now, is this a bid to beat America to Mars? Do we want to beat America to Mars with this? Yes or no? I'm sorry. First question, what mass to low Earth orbit is your Roscosmos Super Heavy Lift rocket going to carry, the new launcher you're planning? And do you want to beat America in the Mars program with this? This is the question.
Нет, я не говорил, что он будет использован в марсианской программе. Первоначально 60-70 тонн, затем ракета-носитель до 150 тонн.
We will develop a heavy lift launch vehicle for 60 to 70 tons of payload, and then it will be upgraded to somewhere about 100-130 tons, but it won't be necessarily used for Mars project.
А что касается энергодвигательных установок с ядерной начинкой, то это совсем другой проект.
And as for the nuclear propulsion modules, it's a different project.
И именно на этом проекте мы реально рассматриваем в будущем пилотируемые полеты, допустим, к Марсу.
And it can be used for the Mars mission. We are thinking about this possibility.
Спасибо.
Okay, thank you. Question for Mr. Dordain from Jim Wald. What is the biggest challenge in terms of getting the best out of the people that work for you? How do you address this challenge? The biggest challenge in terms of getting the best out of the people that work for you. I don't know, this is one of your workers which addressed this question. But I think I can open it a little bit. So we are sort of at the edge of very new challenges. All of you gentlemen mentioned, and we need enthusiasm in the public and maybe in the agencies also. So maybe in this direction.
No, this is true. That the best way to motivate people is to offer them short-term milestones. I think that the worst for someone, and I have crossed this type of situation. The worst for people is to have a milestone which is delayed and delayed. As I said many times, we have to put the future much closer. To have milestones in 2020 or in 2035, this is certainly not the best way to motivate people. And we have to work together. When I was a young engineer, at least it was fantastic. 4 years between Sputnik and Gagarin, less than 10 years between Gagarin and Neil Armstrong on the moon. Things were going quickly, and it was very easy to be motivated at that time. Today, unfortunately, the pace is slower, and this is where, I have expressed myself several times on that. This is where the cooperation can be detrimental, because the competition is the best way to increase the pace, and this is the reason why cooperation should not be to the detriment of competition. I think that some competition is interesting for the engineers of scientists because it increases the pace and it puts the milestones closer. And this is what I am trying to do. Not easy, because obviously to do that you have to have the budgets on time, you have to have the political decisions on time, but this is, in my view, the best way to motivate people, be it my colleagues of ESA, because nobody is working for me, they are working with me. I never consider that they are not working for me. But we are working together to make sure that we shall deliver, because what we have to do is to deliver. And what I wish is to deliver things quickly to make sure that we shall get a new challenge regularly. And this is certainly the biggest challenge for me.
Thank you. You all work together for mankind, and maybe it's just a matter, on the one hand, of the big headline projects, on the other hand, of the many projects where it's necessary to tell the people again and again that they are benefiting out of this. Mr. Bolden, the budget request for NASA 2011 includes, I think, $2 billion for climate change projects. This is a clear thing where all of us can benefit. So maybe a short idea you could give us what initiatives we may estimate out of this field.
I think if you look at, I talked about accomplishments in 2010, 2009, they foretell of where we will be going in the future in terms of what I learned from my Indian counterparts they call societal needs, taking care of the environment, looking at climate change, looking at those types of issues. You will see us extend the amount of effort that we put into a program, for example, called Surveyor. Our dominant partner is the U.S. Agency for International Development, but we presently have 2 Earth sites that take 30 years worth of Earth science data along with contemporary data that comes down, and we feed it to any country in need for disaster management, water resources management, crop planning. We have 2 facilities presently, one in Panama that services Central and South America, one in Nairobi, Kenya that services about 15 East African nations, and we will be leaving this conference and a few days after that going to Kathmandu in Nepal to open our 3rd Earth science site that will service India, Pakistan, Afghanistan, and the sub-Asian continent with the same thing. If I look at aeronautics, we have helped industry in the Boeing 787. You see Chevron nozzles on the back of the airplane. Those have an alloy that we say it's a memory alloy. It remembers where its optimum position was from a flight days ago, and when it gets to a certain place in the altitude, it expands or contracts to optimize the efficiency of the engine. Cuts down on noise, cuts down on pollution from NOx and the like. So those are the kinds of things you're going to see NASA do in next year and the coming year, spending a little bit more money on meeting societal needs.
Thank you, Mr. Radhakrishnan. In your official Space Vision 2025, ISRO is phrasing enhanced imaging capability for natural resource management, weather and climate change studies. This is the Vision 2025. So on that road, in which line section you are today?
In fact, climate change and environment becomes one of our priority for the space applications. Essentially inspired by the fact that about 26 of the essential climate variables are best seen through the satellites. We have been studying some of them. There are a few satellites, but the constellation of remote sensing satellites from geo as well as polar orbits that we are putting in the next 2 years are going to give us a lot of information, whether it is ResourceSat, whether it is OceanSat, or the InSat 3D. But currently, we are working on 2 important missions. One is for the aerosols and the other trace gases. In fact, this is an area we do find that we could have international synergy in the observation. Then retrieval of the parameters which are required on a systematic basis, and an institutional mechanism along with those who collect the ground truth, sea truth, air truth. It's an integrated program that we are planning to evolve, nationally, internationally.
Thank you, and I would like maybe close this climate change round with a question for Mr. Tachikawa. Mr. Tachikawa, how important is that climate change topic for you and the possibility to manage natural threats by the help of space activities? I think this also a special field in your activities.
Okay. I think we should think about 10 years ago, almost 10 years ago, 2001, or Earth Summit, means including top prime minister or president together in the world to get human beings should consider more environmental issues. So Japan is has placed a priority on implementation of disaster management, climate, and water circulation. So JAXA is developing or operating several Earth observation satellite systems under such a suggestion or instruction by the Japanese government. So we have done some good result. Number one is green gas observing satellite we call Ibuki, GOSAT, which was launched last year. We have already many data, a variety of data, so we can distribute such a data through the world, especially for researchers and academians. Also, we launched AROS. It's another land observation satellite in 2006, which can apply for disaster management. So we are contributing such a disaster management in the world. Of course, providing such a data for through a disaster charter. And so next issue we should do is now we are preparing several projects. Number one is a global change observation mission. We call a GCOM. So next year we will launch a GCOM-W. It means water cycle change observation satellites. And also climate change observation satellite we call GCOM-C will be, say, launched around 2014.
I'm sorry, I might to cut a long story short, but I have to look
so
that we are a little bit running out of time, so but we do recognize that there are many special projects on this field. I would, thank you very much, Mr. Tachikawa. I would go on with one of your questions, and this goes to Mr. Bolden. A question, is it possible to increase the space industry market through more cooperation with the developing countries? Question comes from Mahmoud El-Sirani. So more cooperation with developing countries.
That's a very good question. We struggle now with facilitating the success of a commercial space market, and I think that's where the questioner is going. Before that market is going to be viable, we are going to need the major partners to get together to help identify the various destinations to which people can go. And as I said before, I cannot overemphasize it. The International Space Station as the only destination for a commercial industry is not, in the long-term interest of that industry, something that I want them to do. I really do want to encourage all of you who are sitting here in the audience who have an affiliation with the commercial space industry to help us help you by identifying other destinations in low Earth orbit. And I mention again, there is everywhere from launching out of the ESA site in Kourou, launching out of somewhere in Japan, but getting into orbits that are different than 51.6 for a variety of reasons. And once we facilitate the success of that commercial industry, that will create many more opportunities for non-traditional partners and small emerging nations that then want to become spacefaring nations, if you will.
Thank you very much. There are many more very interesting questions I have here, but I think we have to answer them then on the homepage. How do the agencies are handling the asteroids, threat issues, and something like that? This is worth a podium by its own. Thank you very much for joining us with your questions. And now briefly in conclusion, I would like to ask all of you with a maybe very short statement. What do you see as the main challenge facing the space community over the next 12 months up to the time when we hopefully meet again in Cape Town to IAC? Could I have one brief final statement from each of you? Please, not more than a minute each. And we start maybe here with Mr. Radha Krishna.
Ensuring the reliability and quality of space systems and the space assets operating well. This is going to be the challenge for us for the next 1 year.
Thank you very much. You saved 40 seconds for the next podium next year. I will take this into account. Thank you. Mr. Tachikawa, the next 12 months, just 2 or 3 sentences. What is the challenge?
Challenge? Any event should be successful through the year. Yeah.
Thank you very much. We go over to Mr. Penhoff. The next 12 months, what do you define as the main challenge facing the space community?
Задач очень много, поэтому надо их выполнить так, чтобы было интересно и не было аварий, катастроф с гибелью людей. Спасибо.
Well, we have a lot of tasks and challenges, so I think main thing is firstly that we have information from these projects we do, and secondly that we don't have some problems and catastrophes with human casualties.
Thank you very much. Monsieur Dorda, what do you foresee for the next 12 months?
I think that there are, in my view, 2 challenges. The first one is, and I agree with my previous colleagues, it's to deliver all our missions successfully. I can tell you that each space mission is a challenge, and when they are successful, I am relieved. And so that it's important, and no failure in the world is good for space. That it's number one. The second challenge, in my view, it's to connect space with the citizens. I think that we have to establish a strong dialogue between space and the citizens, because the awareness from the citizens of the importance of space is not yet there. And I think that this is certainly our fault, but that dialogue is certainly very important.
Thank you. Mr. Bolden.
The next 12 months, I think we have short-term challenges and long-term challenges. The first 2, like Jean-Jacques said, for us at NASA, our number 1 short-term challenge is to safely fly out the space shuttle program. We have 2 more flights. Every one is difficult. They don't get any easier because you've done them before. The next challenge for us is to help facilitate a cohesive agreement within the U.S. Congress. It may seem like an American problem, but it's a problem for this community because we are the acknowledged leader of human exploration anyway. I think Mr. Permanoff even said that when we were in Tokyo. So we do feel a certain sense of responsibility to maintain our leadership, and that will require our Congress to come together and give us a meaningful budget that we can use. And then long term, for all of us, it's continuing to inspire the young people who are here in all of our nations. We have about 75 students that we have all sponsored to be at this Congress. And I had the privilege of speaking to another group of about 200 who came to the Space Generation Congress on Saturday evening at the end of their time. They are fired up. I mean, they're excited about the future, and the responsibility of us sitting on this podium is to make sure that we educate them well so that they can take over the leadership from all of us. We are not around much longer in these positions.
Thank you very much, gentlemen. Thank you very much indeed. I think we now have more than enough to discuss in the workshops they are following. Please let me announce that the next plenary session will be tomorrow morning, 8:30 in Forum Hall, with the topic Impact of Government's Space Policy Changes on Industry. Thank you again here on the podium. Have a nice day in Prague, and thank you for joining us. Thank you.